So our last two presenters today before interactive discussions are two well-known experts. First of all, Bruce Silver. Everybody familiar with his methods of styles, and now he is author of three the most popular books and methodological books covering BPN, DMN, and now case management standard. And Bruce worked together with Matteo, who is one of key developers of one of the most popular rule engine known as Drools. And Matteo also is a key person behind DMN TCK. So if these two people want to present how to make DMN modeling business friendly, they're probably the right people. Bruce, please take over.
Okay, thank you, Jacob. So in decision management, subject matter experts in the business traditionally have provided requirements handed off to programmers for implementation. But DMN actually is based on the premise that subject matter experts should be able to provide not just requirements, but the executable implementation themselves. Now, in the old days, the business would create text-based requirements documents, and we all know that didn't work out too well. Then 2010, Barb and Larry came out with the decision model, and that gave business users a methodology for creating model-based requirements that could be examined, at least visually, to ensure completeness, consistency, and maintainability. And TDM brought necessary discipline to business-oriented modeling. But without the ability to execute the models, the logic could not be checked for correctness. DMN, on the other hand, provided model-based execution so the logic could be tested for correctness, but it left discipline and methodology to individual practitioners. Myth and style decision table analysis essentially marries many of the principles of TDM with the concepts and syntax of DMN, allowing both validation that the logic is complete, consistent, and maintainable, and testability for correctness. It focuses on decision tables, the most familiar and business-friendly form of DMN logic. Because condition cells are limited to what DMN calls unary tests, decision tables can be statically analyzed for completeness and consistency directly in the modeling tool. Completeness means no gaps in the rules. Overlapping rules are allowed and are resolved by a table attribute called hit policy. The decision table analysis feature can detect gaps, overlaps, and errors in a hit policy assignment. Maintainability also includes ensuring the table is contracted, minimizing the number of rules, and selecting the best hit policy for the table. Testing all of these issues in a tool has become progressively more difficult as DMN has evolved now to allow import of BKMs, decision services, and data types from other models. An often neglected element is testing the logic for correctness. While a subject matter expert, by definition, is the one who knows whether the decision output for a given set of input values is correct, the concept of test cases is utterly foreign to these modelers. Tools can help with that as well. Now, I've been providing DMN training for several years now, and I see every day that these modelers need help. Empowering business to create executable decision logic cannot succeed without providing them with a disciplined methodology backed by features in the modeling tool. So we're going to show you today decision table analysis, including the new hit policy recommender feature and an experimental test case generator feature. So this simple decision table here contains all kinds of problems. It's incomplete, it's inconsistent, and it's not fully contracted. You could scrutinize the table and pick out the errors visually, but it's much easier for the tool to do it. So in the Trisotech tool, when you click on the decision table analysis icon, you get a list of errors and warnings like this. There's a gap in the rules for credit score greater than 660 and DTI greater than or equal to 35% and less than 38%. Rules 4 and 2 overlap, but hit policy U or unique does not allow for overlap, so this is an error. And the table is not fully contracted since rules 1 and 3 could be combined into a single rule. Hit policy A or any means rules may overlap if they have the same output value. A table with no overlapping rules in hit policy A is not technically incorrect, but the hit policy really should be U or unique. And hit policy P means overlapping rules may have different output values, but if all overlapping rules in a P table have the same output value, the hit policy really should be A, not P. And students make these errors all the time. The hit policy recommender, a new feature of decision table analysis, now detects them. Test cases. Developers take test cases for granted, but business users are completely unfamiliar with them. Once you have the decision logic defined, you want to create sets of input values that fully exercise the logic to see if the outputs are what is expected. Remember, the reason we call these folks subject matter experts is because they are the ones able to tell whether the outputs are expected or not. As part of certification in my training, I asked students to create a success test case and an exception test case for their model. And this typically results in one test case with only the best values for all the inputs, and a second test case with only the worst values for all the inputs. And that does not really exercise the logic very well. So modelers definitely need help with this. If you tried to create a test case for every possible combination of input values, called complete coverage, you'd need far too many. In this decision table, which represents eligibility of a mortgage for purchase by Fannie Mae, input 1 requires 3 test values, input 2, 5, input 3, 3, and input 4, 5, giving 3 times 5 times 3 times 5, or 225 test cases required for complete coverage. So we need a way to define far fewer test cases that still substantially exercise the logic, and then generate those test cases automatically. So in the field of automated software testing, one solution to this problem in general is called Modified Condition Decision Coverage, or MCDC. It comes out of the field of avionics, where safety is paramount and complete coverage is usually impractical. The rules of MCDC are as follows. There's at least one test case resulting in each decision output value. And for each input, there is at least one test case for each enumerated value. And there's at least one test case in which the value of that input independently determines the decision output, meaning all other values for that input result in a different output value for the test case, holding the values of all the other inputs constant. And in that case, instead of multiplying the counts of enumerated values of each input, as in the full coverage case, the count of test cases is approximately the sum of those counts, and sometimes even fewer than that. So approximately 16 test cases instead of 225 for this decision table. Now, it's one thing to know the principles of MCDC, and quite another to have an algorithm to do it. In the published work on MCDC, the inputs and often the outputs are assumed to be Booleans. So some adaptation to DMN decision tables was required. The algorithm requires enumerating test values for each input, then picking one input to start and a value, call it in1, defining a positive test case with output value, call it out1, such that all other values of that first input other than in1, while retaining the same value for all the other inputs, give negative test cases having some output value other than out1. And then you need to repeat this until you have positive test cases covering all the inputs and all the enumerated output values. At the end, you combine all the positive and negative test cases and throw out the duplicates, trying to minimize the total count by maximizing the duplicates. And if it sounds messy, it is. Things that affect the resulting count of test cases include the order of processing the inputs, and for the selected input, the test value chosen. Our algorithm requires enumerated test case values for all inputs and outputs. So in the case of continuous data types, we need to determine the test case values for each input from the decision table input entries. Now, I messed around with this in Excel and found something that seemed to work. And then I asked Matteo to do it for real in Java. And he didn't say no. So to set the stage, I'll quickly go through my heuristic, which you can review in more detail later. And then Matteo will go through the implementation. So based on the property usage, the loan to value ratio, debt to income ratio, and the reserves, this decision table shows the borrower's minimum credit score required to qualify for a mortgage. As noted earlier, 225 test cases are required for full coverage, but we want to do it using MCDC in far less, around 16 or fewer. So to make this easier to follow, I've converted that decision table to an equivalent one using enumerated instead of continuous input values. To pick the first input to try, we select the one with the greatest number of allowed values. And that's either LTV or reserves with 5. So let's pick reserves. Now, which value do we pick for the first positive test case? The one that matches the most rules is one approach, and that would be 7 or 13. So let's pick 13. We then need to find test case values for the other inputs so that all values of reserves other than 13 give a different output value than the one with 13. So I picked usage S, LTV 74, and DTI 37 with output 640 for the positive test case, shown on the left here with the changing input reserves highlighted in yellow. And on the right are the 4 negative cases, all with output other than 640. We keep going. The next input is LTV, and we start with the enum 74 for that. We favor test cases that have a different output value than the one we already had. Here's 620. No duplicates yet. Next, DTI with enum 37 and output 700. Here we have one negative test case that's a duplicate. That's good, shown in red text. So now we have 12 unique test cases, including one duplicate. Then usage, looking for a new output value. So we pick S74, 37, and 1 for the 4 input values with output 660. That's good because it duplicates a previous negative case. So again, we show it in red text. Now we have positive test cases for all 4 inputs, but we need positive cases for the missing output values, 680 and 1000. Those last couple using this method often are pure duplicates of previous cases, so they add nothing to the count. So there you have it. Only 14 test cases for MCDC coverage. Now, doing it by hand is maybe cheating a little bit. So, automating this in software is hard, as is, for example, decision table analysis, consolidating adjacent gaps in the rules. So I'm going to hand it over to Matteo now to explain how he did it. And I will.
Hey, just while Matteo is getting his screen shared, Jacob had a question about how the described MCDC algorithms sound like they're solving a constraint satisfaction problem.
It probably is, but I would say in none of the write-ups that I've seen about it. First of all, I'd say there's a number of software testing tools that provide this, and they all do it differently because they all interpret MCDC a little differently. And none of them really describe their algorithm, how they do it. And certainly none of them mention constraint, although I can see that technology would be very useful. So like I said, I had this heuristic, and then Matteo implemented it in Java, but it might be that a constraint system like Jacobs could do it very well.
Thank you, Bruce. I just ask if Sandy, please, to double check that is now my screen sharing. So in this part of the presentation, we will delve into some of the technical aspects, and we are going to show pragmatically with a demo how we implement these static analysis features. We hope this can be helpful if you want to integrate this feature into your own platform or product by reusing the key demand validation that we're going to see. Or if for any reason you have to implement it on your own, we really hope this can provide for you some really helpful lesson learned that you can take away. When we speak about the key demand validation in particular, we provide a set of static analysis features for DMN models. And it has, for instance, the validation of the DMN model file against the XSD. This is a trivial check, of course, but also we perform still some static validation on these model files. For instance, we have pre-compilation and pre-processing checks that perform semantic validation. One example, in the DMN model, you should not have duplicate names. You cannot do this check with XSD checks alone. So we perform a set of semantic validation on top of the model after it's valid from purely from the specification XSD. For a fun fact, all these validation rules are actually defined using JAWS rules. And I want to mention that because I believe it's really funny for us to see this dogfooding project and application. We have, of course, compilation or processing phase checks and decision table static analysis that Bruce have introduced. We implement method and style checks that Bruce have described. We perform semantic checks against the DMN decision table semantics. We have the policy recommender feature and the MCDC test case generator. So for the presentation of today, we're going to focus on decision table static analysis feature. And when we talk about this, there are really two dimensions to look at. One dimension is the feature set, is the one that you see on the left. For instance, we check that there are no gaps in the table so that the table shall be complete, or that if there are overlaps in the rules of the tables, those must be consistent with the table policies. We have, of course, other type of checks like subsumption, rule masking, misleading rules, and so on, likewise normalization checks. So these are the features that we provide to the end users. But there is as well a cross-cutting concern. It's really another dimension, that is, this feature must be consistent with the DMN expectation. I believe that if I make an example, I make this more clear. In DMN modeling, you will find often that people will import some models in their structure diagram. This is because maybe you have item definition that are defined as a sort of like a domain object in a standard library of DMN models. So any checks must be consistent with that. Likewise, in decision table, you have sometimes weird or edge case of null handling. So we are consistent with that. Likewise, in decision table output, you have field expression at times. The validation checks takes this into account. Another example, maybe it's more immediate, in a decision table, when it looks like to the validator that the values should be coming from an enumerated item definition, but the modeler has missed to do that, we inform the modeler so we can take it into account. So overall, this is to say that the consolidated messages coming from the validation should really be user-friendly. An example also can help here. Likewise, the DMN is, of course, an interoperable specification. Also, the key DMN validation is fully interoperable between tools that support DMN. In this case here, we have the Trisotech DMN modeler on the left and the Red Hat open source editor on the right. And you will see that the messages that the validator produces are the same for the same table. One specific case that you can see here, item definition are imported in this table, and the validator is taking that into account. And the messages have also the proper error level or icon or color, whatever you want to describe, for the correct level that we expect. An example, here in this table we have a gap, so the table is not complete, but this is we represent by default as a warning sign. So the modeler is advised for that and should address this problem, but is a sort of like optional. Likewise, instead, another message here, it's really problematic, is the one about overlaps. So rule number 2 and rule number 4 overlap from some values, and this would be a problem at runtime when you are evaluating your model in production, because by the DMN specification, a unique hit policy table should only match for one rule. And for these values that we provide at before runtime, so during modeling stage, we provide to the modeler this message, and we say that is an error. So this must be addressed before these models are being ported into production. Let me give you another example, actually also a funny one coming from a previous DecisionCAMP. This is an example of what was called a misleading rule, and we might be tempted to say that for the output value check, it's when you have risk evaluated as medium. This is like if you're just glancing at the table, this is what you might be tempted to say. However, if you do the exercise to refactor this table from a priority to the unique hit policy, you will find out that also the is mitigated column must be true in order for this output value to be checked. This was called a misleading rule in a previous DecisionCAMP, as I mentioned. It was described, defined, but not implemented at the time, but now it's part of the static validation. Let's move here. I'm going to show you a lot of demos. The hit policy recommender, and as Bruce has introduced in a nutshell, it will try to recommend to you a more appropriate hit policy whenever possible, depending on gaps or overlaps in the table. So you should be seeing now a first example, and what we have here, it's a table that describes for different sound level in decibel if the sound level is no risk or considered harmful or a danger. And if I run the validation against this table, what we will see is that actually you will get a message that let me just open it up a little bit more. So the hit policy here, unique shall be preferred, and we always advise modeler to use unique hit policy whenever preferable. This is a simple table, but the concept translates really well also for more complex table. This is fully automated. Let me jump to another example here. So similar table, but this time it's a bit different. So let me clear this and validate this other table. So here actually we are making a more stronger messages, and we are saying that the validation hit policy should be any, because this, as we've seen, this would be a problem because the table is unique. So if we hit for a value that might hit the two different rows, this will be a problem. So we are detecting this earlier than runtime during modeling phase. And so if I change the hit policy to the one recommended by the validator and I save it, now the error has disappeared. One last example of the hit policy recommender is, and this relates to what I was mentioning about consistency with DMN expectation. So in this case, we can validate the table and see what is proposing to us. It's proposing to us that, well, here there are two concerns. One is that the table is using the hit policy first, and this is normally discouraged. Another thing is that the hit policy recommender has suggested priority. This is because for this table, actually, you will see that we have enumerated output values. So we suggest the end user to use priority because it will be consistent with the expectation. Let me just jump right back. In the presentation, in the slides, you will find a screenshot for this demo. And we can move now to the MCDC test case generator. As Bruce has mentioned, this is completely automated. It's not integrated in our editor because we are still experimenting with some of the features here, but we provide an analytical representation in Excel form, similar to what Bruce has mentioned, as shown in the slide, but also we serialize it as a DMN TCK test case format. This allows us to interchange these test values, but also allows us to use this TCK produced format automatically in order to execute it and to automatically run the test. I can just run a real demo real quick. Actually, this one I've already started, so I'll just restart it again. What you will see that it will happen is that oops, sorry, okay. This is my screen, right? Okay, so you will see that the generator have actually computed the values automatically. If I also, here I bring up, okay, the generator automatically produce an Excel file that is consistent with the convention that Bruce have originally described, and we use it as an interchange format between human to human exchanges here. But also we have automatically the TCK format described, and this is for the example table that we've been seeing throughout the presentation of Bruce. So this is the model table that we've been seeing. I can just take 1 minute more to show the example for if the computer assists me here today. Okay, so this is running for the second example. And okay, a lot of windows open. I hope that you can follow. This is another example table. I can show you to you real quick. It's for approval for a book loan. So we have several input columns, and as Bruce mentioned, this will generate a made account approximately 360 combination. Of course, we don't want to do that. So we actually generate a few, the one that you see here. We've taken the time indeed to try to make this TCK format usable, also with the description that you will be able to also see it when you run the test with the TCK runner. This is really showing the power of interoperability. So just last point, as we've seen briefly, this is automatically implemented with the heuristics that Bruce have described. I won't go into the fine minutiae detail about this, but you're welcome to join the conversation, and it's an open source project, so we can collaborate on that. So as we said, we take a decision table, we generate actually two formats, an Excel that is helpful for, let's say, humans, and a TCK format that you can immediately use it if you want to integrate it into your own product to do. One last point, and more a very technical things that I would like to make a shout out, is that as software developer, we are sometimes often concerned about having full coverage of the table. So please, if there are any developers listening and looking at this presentation, don't make the mistake to assume that the goal of this is to cover every possible row in the table just by itself. I'm not arguing against. What I'm trying to say is that, as Bruce have introduced, this is a tool that we are using to provide business expert a set of an automated computed set of business requirements, are the one that you see in this table, so that the people who have described the table, the decision table in DMN, can actually have a look at this set of sensible test cases that, according to the literature that Bruce has mentioned, are relevant to test this table, and they can also confirm, yes, these are the expectations that I want to do about. So if there are any developer, Java programmer, or any programmer out there, please, when you will see this feature, keep that into consideration. And with that, I thank you for your attention. In the slides, there are a few references that you can use. Thank you.
Great, thanks, Matteo. Bruce, you might also want to open your mic up just in case there's some questions that that you can respond to as well. We had a question from Falco about how about using equivalence class partitioning for continuous values and then just testing exactly at the boundaries of the range expressions used in the input entries.
Yeah, he had a reference, and I'm not familiar with that. I mean, a test case for an input, I mean, is a value, a single value. And so maybe I don't really understand what this equivalence class partitioning does. I mean, when we have continuous values, generally from the input entries that might specify a range or endpoints greater than the value or less, you can translate that set of ranges into isolated test case values that cover all the possibilities of the input entries. So that's a fairly straightforward thing. So I'm not familiar with this equivalence class partitioning, but I'll look into it. Okay, and definitely you know, continue the discussion on Slack if you get a chance to check that out. Jacob was asking, how about testing across multiple decision tables within the same decision model? Yeah, I mean, one of the issues in why this isn't like in the tool is that this methodology, at least as far as we've done it, works on a single decision table, and that decision table might be embedded in a larger DRD, and really you might not control the inputs to that decision table, you just control the input data to the DRD. And for some cases you can actually work backwards to get from the decision table input test case values to the input data in test case values, but in the general case you cannot. So I would say we haven't figured out how to, I haven't figured out how to do that, solve that problem yet. So right now this, the algorithm that we've developed just works on isolated decision tables with the input values for that decision table. But in reality, it would be best if we could do it for the whole DRD, for all the decision tables in the DRD. I don't know how to do that.
Yeah, and also just briefly to add one point on that, when we speak about it, so to do it for any possible decision logic that the DMN described, it will be, it's not impossible, but it will be very complex, especially when you factor in stuff like DKMs that you might call out to external services and so on. So for the case here, it's really, and you can do that, actually the TCK allows you to do that, is that you expect that a modeler have been describing a decision table, and so you make it robust in there. So it corresponds more to what I would say a unit test more than a full integration test, if that also helps.
Yeah. While we're on this discussion, I just add 2 cents. Actually, it's related not only to testing, but also to checking for completeness and for conflicts across multiple tables, because people always concentrate on one table, but it's what's the interest if the entire decision model fails, it doesn't produce expected results. So one of the approach what was proposed in previous years is to consider the entire decision model again as constraint satisfaction problem. All constraints are posted from decision tables themselves, and when you solve the entire problem, you have three solutions. No solutions, it means conflicts there, and we can point where is conflicts. One solution, everything is okay from DMN point of view, or multiple solutions that again tells you that anti-coverage is present. So that's probably the way to go.
Could I make a comment on a couple of the issues that have come up in Slack?
Mm-hmm.
So,
Please do.
there's comments about lovers of first hit policy and haters of priority hit policy. So the reason why first is, I would say it's quasi-deprecated in DMN. It's allowed, it's there, but maybe it's quasi-deprecated. The reason why we have this error or warning for it is, as I said, comes from the many of the principles of TDM, where it's really based on declarative logic as opposed to a procedural logic. I admit that there's some F tables that are difficult to reproduce in some other way. I mean, the logic is more complicated. But that's why we discourage it. Some people say they don't like priority tables. That's you're right. That's fine. I would say it is easy to create misleading rules with priority tables if you don't know what you're doing. Okay, but there are certain use cases for priority tables that are very valuable, and particularly what I call the else rule, where you have one of the rules in the table is all hyphens, meaning basically it matches everything, and if that is the lowest priority value of the enumerated outputs, that works, and that often makes very much smaller decision tables than if you tried to use a different hit policy. So, and we focus a lot on that in the training. So I would say, you know, if you just look at the spec and you try everything that's possible, yes, you can get into trouble. But if you learn the methodology for using the right hit policy in the right situation, you can usually avoid those problems.
Okay, that's great. We're about out of time here, but I see there is quite a lively discussion going on Slack. So if you guys would like to, you know, respond to that as you can, and we're going to get ready for our closing panel for the day, which is our Ask a Practitioner panel.